Hey there, science fans! Today we're diving into the world of ionic bonds. You know how magnets stick together because of opposite poles? Ionic bonds are kind of like that. Early in the 20th century, two brilliant scientists, Gilbert Lewis and Irving Langmuir, figured out how atoms become attracted to each other. They called it the octet rule, where atoms try to have 8 electrons in their outer shell. It's like a dance where everyone wants a full dance card. Ionic bonds happen when atoms give and take electrons to fill their outer shells. This exchange creates charged particles called ions. One atom becomes positively charged, losing an electron, and the other becomes negatively charged, gaining an electron. Remember, opposites attract. This attraction between oppositely charged ions is what forms the ionic bond. These ionic bonds are the backbone of many materials we use every day. From the salt we sprinkle on our food to the ceramics in our homes, ionic compounds are all around us. So let's explore the ins and outs of ionic bonding, starting with a classic example, sodium chloride. Let's picture a sodium atom meeting a chlorine atom. Sodium, Na, has one lonely electron in its outer shell, while chlorine, Cl, has 7. Remember the octet rule? Both atoms want a full outer shell of 8 electrons. Now, sodium, being a generous atom, decides to give its extra electron to chlorine. This act of giving and taking electrons is what creates ions. Sodium, losing an electron, becomes a positively charged ion, written as Na+. Chlorine, gaining an electron, becomes a negatively charged ion, written as Cl. Now we have two ions, Na+ and Cl. But what happens next? Remember how magnets stick together? These oppositely charged ions attract each other, forming a strong bond. That, my friends, is an ionic bond. Let's recap. We start with a sodium atom which has 11 protons, positive charge, and 11 electrons, negative charge. This makes it neutral overall. Chlorine, on the other hand, has 17 protons and 17 electrons, also making it neutral. When sodium loses an electron, it now has 11 protons and only 10 electrons. This imbalance creates a net positive charge, hence the Na+ ion. Chlorine, gaining an electron, now has 17 protons and 18 electrons. This imbalance creates a net negative charge, hence the Cl ion. This exchange of electrons is crucial for forming the ionic bond. Without it, the atoms wouldn't have a reason to stick together. Section 4. Lattice energy, holding it all together. Now imagine billions and billions of sodium and chloride ions coming together. They don't just form a random jumble. Instead, they arrange themselves in a repeating three-dimensional pattern called a crystal lattice. But what holds this lattice together? It's all thanks to something called lattice energy. Remember Coulomb's law? It tells us that opposite charges attract, and the force of attraction depends on the strength of the charges and the distance between them. Lattice energy is the energy released when these ions come together to form the lattice. The stronger the attraction between the ions, the higher the lattice energy, and the more stable the compound. Section 5. Size matters, ionic radii and bond strength. Here's a fun fact. The size of ions, known as ionic radii, can also affect the strength of the ionic bond. Smaller ions can pack closer together, leading to stronger attractions and higher lattice energy. Think of it like trying to fit different-sized balls into a box. Smaller balls pack more tightly. For example, sodium chloride has a higher lattice energy than potassium chloride because sodium ions are smaller than potassium ions. So even though both compounds have the same type of bond, the size difference affects their properties. Understanding ionic radii helps scientists predict the properties of ionic compounds such as melting point, boiling point, and solubility. Section 6. Ionic compounds, the salt of the earth. Ionic compounds are everywhere. From table salt to baking soda, these compounds play a vital role in our daily lives. They're used in medicines, fertilizers, cleaning products, and even in the production of metals. So the next time you sprinkle salt on your food, remember the amazing world of ionic bonds at play. It's a story of give and take, attraction, and the incredible power of tiny particles to form the building blocks of our world. And that's ionic bonding in a nutshell. Keep those science brains buzzing, and I'll see you next time for more exciting adventures in the world of science.